Afternoon and welcome back to Math Concepts. We are going to continue our work in conditional probability. In this video we are going to look at the effect of drawing without replacement versus with replacement. Okay? In the situation where we make selections without replacement, that's typically going to lead us to conditional probability. In other words, the sample space will change from one draw to the next. If we are drawing with replacement, in other words, taking something out, looking at it, putting it back in, that will typically be the same sample space. So let's go to the document camera and look at a couple of examples. So the key idea from this video is using conditional probability both with and without replacement. Alright, so we're going to imagine that we have a bag that contains 5 red marbles, 4 green marbles, and 8 blue. And we want to find the probability of drawing 2 green followed by a blue. And in the first scenario we look at, we'll imagine this is done without replacement. So we take a marble out of the bag, we keep it out, and then we draw the next one. Okay, so let me just keep a tally over here. 5 red, 4 green, 8 blue. So that leaves me with 17 total marbles. Okay, so we want to draw 2 green followed by a blue. So let's think about the probability that the first marble is green. Well, there are 4 green marbles out of 17, so the probability of drawing green is 4 out of 17. Now that's on the first try. Now, let's look at the second stage of the experiment, because we want to draw 2 greens in a row, and this is done without replacement. Well, if your first marble was green, there's only going to be 3 of them left. And there are only 16 left in that second draw, right? Because we're not putting the marble back. So, first try, there are 4 greens out of 17 total. If we take one of the greens out, then there are 3 left out of 16. And now the next one we want is a blue. Okay, now there are 8 blue, but this is the third draw, so there are only going to be 15 marbles left. Okay, we can multiply across. 4 times 3 times 8 for the numerator gives me 96 on top. And on the bottom I have 17 times 16 times 15, 4,080. And then I could do an approximation if I wanted. I could do 96 divided by 4,080 and get 0.024 to the nearest thousandth. Okay, now that's the situation if we do this without replacement. In other words, we keep the marble out. Let's see how the situation would be different if we repeat the experiment, but we do it with replacement. Okay, we're still talking about drawing 2 greens and then a blue. Alright, so it starts out the same way. You want to draw a green on your first try, you got 4 greens out of 17 total. So you're going to look at that, you're going to write down what you get. You got a green, okay, great. You're putting that green marble back. So on the second draw, you still have 4 greens out of 17 total. You look at that, you write down what you got, you put it back. And now you want to draw a blue marble. So there were 8 of those out of 17 total. Okay, so notice the difference in the denominators here. If we are replacing the marble every time, then we always have 17 marbles to choose from. Without replacement, it's dropping by 1 every time. Notice the numerators are also different. Okay, so we could do a little number crunching here, get what we get. Numerator is 128, denominator is 17 power 3, 4913, so we could get an approximation for that with our calculator easy enough. All right, so that is the difference between doing something without replacement and doing it with replacement. And another thing I want you to notice is that this is a conditional probability. The probability of getting a green on your second draw is 3 out of 16, given that you got a green on the first draw. Okay, because we started out with 4. If you're taking 1 out on the first draw, then you only have 3 left. All right, and this is also a conditional probability. This is the probability of drawing a blue marble given that 2 green marbles have been taken out. Okay, so this is just a standard probability. These two are conditional because the sample space has changed.